lot, Wilmer. Indeed, then it leaves us a few minutes for the last questions that participants may have. I received a message from Martin who would like to complete on a question that was asked during the first Q&A session. Martin, if you want to complete.
Thank you, Marine. Alexander, is it possible to share my screen?
For some reason, it doesn't respond at the moment.
Okay.
Okay, now.
Okay, I will go. So in the former Q&A, there was a question on what is the energy consumption from shopping centers compared to other non-residential commercial buildings. And so I found a presentation I gave in the past, and just the difference between residential buildings and shopping centers was mentioned by Wilmer already, that it's a very different approach. But what is actually crucial if we go to the energy consumption of shopping centers is to see which kind of shops are in there. And so based on research done in the past from other projects, we saw that, for example, clothing have a energy consumption of around 180, while if you go to supermarkets, it's around 456 kilowatt hours square meter annual. So it's really depending on what kind of shops are being used in the in the shopping centers. And then what this project actually did is that they aggregated data from real estate companies and shopping center databases, and around 132 shopping centers and their gross leasable area have been analyzed. And they show that actually the smaller the shopping center, the higher is the share of the supermarket, and therefore also the higher their specific energy consumption. So it is rather a question of which kind of tenants and shops are in the shopping center that are depending on the final energy consumption. And if I compare these numbers to other numbers I have from non-residential and commercial buildings, it's quite similar. So the key storyline here is that it's really depending on the energy on the tenant as such. Marina, I give back the floor to you. Oops.
Thank you, Martin. So I think we got a few more questions. I see already one asking how we approached the occupant behavior, and if the people responsible for operating the building are able to use our technologies, and finally how to motivate the tenants. So I think it could be Magdalena, Stefano, or Wilmer answering this question. I don't know who wants to grab the mic.
Okay. May I, Stefano speaking for Schneider?
Yes.
Okay. Regarding the question, for the people responsible for operating a building, we perform some training, very simple training, on how to interact with the system. So not how to program, of course, the building management system, but how to interact, see the different values, what they have to change. And together with the user, final user, we developed the HMI, so the human-to-machine interface, in order to have the most clear and simple way according to the different user for managing the system. Then the other question, how did you approach occupant behavior? Maybe not the right person, but during the process of the project, we make some audit inside some shopping center in order to understand how the occupant was feeling for the temperature, inside the luminosity. They make some questionnaire. So before and after the installation of the solution, in order to evaluate also how the people react to our solution. I don't know if Wilmer wants to add something.
If I can add something there. About occupant behavior, is not shopping centers are not like, for example, residential buildings where an occupants can make a difference in terms of energy consumptions. Here, if by occupants you mean the customers, usually they just are affected by the indoor environment, but they cannot impact the indoor environment. So there are no action they can take to change the energy consumption of the indoor environment. Quite similar, we can say something also about the tenants. I mean, the tenants, they actually, especially if they are big chain, they have already policies about how they need to control their the indoor environment, mainly about lighting in this case. But there is not that much they can change. But yes, in this type of buildings, they are very. We're talking about all mechanical control buildings, so really there is not that much room to have an impact from occupants on the building itself.
Thank you, Wilmer. I know Magdalena has to leave soon, so I will ask her the next question. Meanwhile, Stefano, you can already read the last long question because it will be addressed to you. Magdalena, did we consider any HVAC systems alternatives such as solar cooling or tri-generation?
Yes, of course. Somehow all passive technologies that you have present form a part of the alternatives for HVAC, as they all delay somehow the use of the HVAC. So in that sense, the most evident is, of course, ventilative cooling that use the natural ventilation, night ventilation. The same somehow avoid the use in that same time the HVAC, but all of them somehow shadowing system, different characteristics that you first use for glass. All that characteristic first, the aim is to protect somehow building, protect against the peaks of sun and peaks of heat. And once that doesn't work anymore, the ventilative cooling dissipates the heat from indoor, and once again delay the use of HVAC. Finally, if the situation and conditions are really extreme, we cannot avoid, of course, and we integrate that HVAC. But what was the part of the research was how far it can delay the use of that. So.
Thank you, Magdalena. Stefano, I don't know if you had time to read the question, but
yes,
the person is yes. So I will only read the related question. Does the IBEMS manage to optimize conditions consumption both overall and locally, or is this an equation impossible to solve?
So it's not impossible, but it's difficult to optimize different conditions for also in a big shopping center, which are as the question raised, there are different usages, different needs, and also different behavior of the people who are working inside or doing the shopping. For example, in the cash line, the people at the cash have a sit down for hours, so maybe they feel more cold than the one came in from the outside. So it's very difficult. But with a good building management system, and of course with a modular plant, means a system that can be for HVAC system that can manage the different areas of a shopping mall. It's possible to differentiate for example, temperature, humidity, and light for different areas. But we are in an open space, so at the end everything will be mixed up, so it's quite difficult. So when we say the lowest common denominator, partly is true, because you have to satisfy different needs and according to different behavior of people that as normally is knows, it's very difficult the behavior of the person regarding temperature and the light, so it's quite difficult. But with a good management, we can find the best points to have the best comfort for the wider area of wider part of the occupants with the minimum energy consumption possible. We can find these optimal points, let me say. Okay, thanks for the question.
Thank you, Stefano. That was the last question, so I think it means that we can end the webinar now. I would like to thank you all for attending, to thank Build Up for the organization of the webinar, and of course all our speakers. We will publish today on Build Up as well an overview article on the project, meaning many links will be made to follow up on other articles, reports that were published during the project. It's quite full, and I invite you to follow up on Build Up to find it. Thanks again, and have all a very nice day.